and welcome to our live webinar on the process of lime production. I'm Almine Teron, your host for today's event, and I'm thrilled to have you all here with us. Lime production is a critical industry with applications ranging from construction and agriculture to environmental and chemical. Before we begin, I'd like to provide a brief overview of what lime is and why it's so important. Lime is a key ingredient in many industrial processes and products. It's used in construction to make mortar and plaster, in agriculture to neutralize soil acidity, and in water treatment to purify drinking water. Lime also plays a crucial role in environmental and chemical engineering, such as flue gas desulfurization and paper manufacturing. Today, we have the privilege of hearing from three distinguished experts in the field who will share their knowledge and experience with us. Whether you're joining us from England, Canada, Mexico, Saudi Arabia, or anywhere else in the world, we are delighted to have you with us. Our speakers will cover different types of lime, how they are produced, and how to determine which type of lime is correct for your application or process. Attendees can expect to learn valuable insights into the lime production process and how to optimize it for their specific needs. Our moderator today is Prince Kangale, an experienced mechanical engineer and senior project manager. Prince recently completed a project involving the supply of limestone and lime slaking plants for a gold mine in Saudi Arabia. Our first guest speaker is Karsten Woodridge, a renowned engineer with over 25 years of experience and having designed over 35 lime plants. We will be discussing key factors in lime type selection and cost implications. Our other guest speaker today is Eugene van Aswegen, with over 40 years of experience in the cement and lime industry. He will be sharing his insights on the lime production process and how to select the correct lime type. Together, these speakers bring a wealth of knowledge and experience to our webinar, and attendees can expect to leave with valuable insights into the lime production process and how to apply this knowledge to benefit their own processes and applications. Before we begin, I'd like to thank all our attendees and our guest speakers for making the event possible. I encourage you all to use the chat function to ask questions and engage with our speakers. Please keep your microphones muted and send us your questions by using the chat in this meeting. So without further ado, let's get started. Prince, I'll hand over to you to kick off the discussion.
Yeah, thank you for the introduction and good day and welcome everyone. I'll be your moderator for this webinar and I'm excited and looking forward to a great discussion. Then, Karsten, Eugene, welcome to this very familiar arena. I mean, the two names which are very popular in this industry of lime. But we can't talk about lime and not mention your names. So let me briefly touch on interconnection between lime producers and Techmatic. Techmatic specializes in materials handling and powder slurring solution, and as such, we get involved with the lime manufacturing processing, with the lime suppliers as well as the end user of the product, where we assist in the processing of the supplied lime for various applications. Doing work for the lime producer and the end client give us a full spectrum of dealing with a product right from the mine through to the end user. So Eugene, you have extensive experience on producing of lime. We hear about limestone, quick lime, hydrated lime. What's the difference between the three, if you can just kick off with this?
Well, first of all, good afternoon to all our listeners. Good afternoon, Prince. And I have to say, first of all, it's an honor to have been invited to this podcast. I've known Karsten a long time. I've known the company a long time. And for my sins, I've been in the cement and lime industry a long time. So I've learned a lot, but still learning every single day. So yeah, thank you very much for this opportunity. I think just from the outset, we're certainly not going to try and teach the chemical engineers on this podcast something about lime. I'm sure they've learned that at Chemical Engineering 101. But it was certainly aimed, certainly from the lime side, to share some basic knowledge, and certainly, as you've alluded to, the correct application and the different limes, more to the layman, and also provide a platform for our listeners. So to your question, and thank you very much for sharing that. You know, for my sins, I've also looked after the agricultural industry. And if you phone a farmer, he talks about lime when he actually means limestone. And you shouldn't correct him, because the farmer then gets very upset. So when you talk to a farmer, know that lime actually means limestone. So, you know, you raise a very, very valid question. But to the point, so let's just go through the generic names and the chemical definition of the three. So limestone is fundamentally calcium carbonate, CaCO3, and is what we mine at our mine in the Northern Cape. And that is what is used to produce unslaked, quicklime, burnt lime for the different applications. So if we then say limestone goes through a kiln, and we'll talk about it later on, it's then at the end of the kiln, we produce quicklime. So the difference between limestone and quicklime is really a calcination process. So it's putting it through a kiln that would run at somewhere between 1100 and 1300 degrees, and we burn off the calcium, the carbon dioxide from the limestone, and we then produce a calcium oxide. And then, of course, the next step of the beneficiation process, to your question, hydrated lime. And hydrated lime is simply a dry powder, i.e. unslaked lime, that has gone through a hydration process, adding about 2 to 3% water through what I always refer to massive washing machines at our beneficiation plant in Vereeniging, as well as the Northern Cape, and we produce a hydrated lime. So that is really, in essence, limestone, then unslaked lime through a kiln, and then hydrated lime through a hydrator or a washing machine. Thank you very much, Prince.
Yeah, thanks, Eugene. It is quite great that you made example of a farmer. From what I'm hearing, sounds like there's so many terminology that comes with lime. Also heard about calcitic lime and dolomitic lime. I mean, what's the difference between the two? I think also while you giving us an explanation on that, if you can also touch on you use the word bent lime. If you can just briefly elaborate on that, then at least we can all understand what you refer to when you say bent lime.
Yeah, I think, you know, in terms of different industries tend to use different generic names for what we call calcium oxide or unslaked lime. So I don't think we need to be too concerned if a customer wants to talk about unslaked lime, customer wants to talk about slaked lime instead of hydrated lime, or particularly in the DRC, customers tend to talk about quicklime. Customers tend to talk about burnt lime, which is fundamentally the limestone that has been burnt in a kiln. I always say whatever makes the customer happy in terms of their reference. And therefore, when we use the words quicklime, unslaked lime, burnt lime, let's just understand in terms of the background that they're all the same. But when we talk to the customer, and I always say whatever makes the customer happy in terms of the reference, let's utilize that opportunity and rather use the words or the definition that the customer is happy with. So when you talk about dolomitic and calcitic, fundamentally, the limestones between the dolomitic and calcitic is going through a same process if we are looking at a burnt lime dolomite or a burnt lime calcite. And it is really just the chemical composition that varies. So in terms of calcitic limestone, the available calcium is somewhere between 95 and 98%. And I'm referring more to the South African market. When you look at other resources globally, you'll find that some deposits may even have up to 99% available calcium. But in South Africa, let's say on average 95 to 98% available calcium. If you then look at dolomitic limestone, the chemical composition is predominantly driven by magnesium oxide, because that is the need that particularly the steel industry or pyrometallurgical industry requires a high level or a high percentage of magnesium oxide as part of the fluxing fluxing process that they need in the steel making industry. So just by comparison, fundamentally, it's the chemical composition that differs, but in the end, producing a burnt dolomite or a burnt calcite lime goes through the same process, i.e. kiln and calcination. And then finally, just to have a comparison, dolomitic limestone or burnt lime would have somewhere between 30 and 42% magnesium oxide, whereas calcitic lime would have a maximum of about 2.5% magnesium oxide. So that just gives you a difference between what chemically is the variation between the two. Thank you, Prince.
Thanks, Eugene. I've got a follow-up, maybe a question on that. Is there any distinguished difference in terms of appearance between the two other than the chemical composition?
Well, appearance, and I've had a look at various photographs for my sins, and I must say again, an honor that I've attended for many years, the International Lime Association conference every year in October, and we've traveled the world, and part of that conference, we visited various lime plants. So when you look at different limestones, I must say it's only when we come to South Africa, and I love my country, I've been here and I have no intention of going anywhere. But in South Africa, we always do things differently. So when you look at our limestone in South Africa, first of all, our deposits are only really available in the Northern Cape, which is some 700 kilometers away from Gauteng. The second predominant feature of our limestone is that it is a different color. And that is because of the manganese that is predominant in the Northern Cape, which gives it the brown color. So again, to your question, between dolomitic and calcitic limestone or burnt lime, not really a big difference in terms of the color. But if you compare ours to the lime in Zambia, let's say in Dola or Handyman's Paradise, or Kemmerman from Thailand, they produce virtually a pure white lime. We also have 2 white lime producers in South Africa, mainly in the Western Cape, and it's fundamentally because the limestone in the Northern Cape contains manganese, giving it the brown color. So that really at the end of the day says, limestone when it's brown or burnt lime when it's brown, you know exactly where it comes from. Thank you, Prince.
Thank you very much for sharing that. Yeah. So just a quick reminder for our guests, you're more than welcome to send questions through direct message to me. I'll pass the questions through Kirsten and Eugene. Feel free to. I just received one question here from one of the guests. I think I'll put that question through to Kirsten. So basically, what is the difference between calcium oxide, unslaked lime, quicklime, and you can still touch on burnt lime as well?
Well, thank you, Prince, and thanks for the introduction in the beginning as well. Well, effectively, all those 4 terms refer to the same product in the end. And I think that is most probably where a lot of the confusion comes in. But as Eugene alluded already, it's really down to which industry uses the product in the end as to which terms they use. The paper industry would potentially use a different term for it. Then you'd get to the metallurgical side of things, which generally use burnt lime. And that just comes back from when it was first produced in, way back, where it was burnt physically in kilns with coal and fire in the end. So burnt lime, as Eugene explained already. So your calcium oxide is effectively the chemical term. It's CaO. And then you go to the unslaked lime. An unslaked lime effectively says there is no water in the lime itself. So it's actually a burnt lime without the water added. Because once you add the water to it, it becomes hydrated lime. Quick lime, I'm not sure where that term comes from, but it's, as Eugene said, up in the Central Africa, that's used quite extensively in terms of the gold and the copper producing companies up there. And then obviously Eugene explained already what burnt lime. So effectively all four terms, the same product, but just different industries that they used. Thanks, Prince.
Justin, yeah, once again, I mean, it's same products with different names, different terminology, all based on the area where it's being used. And I think it's quite common in the industry for the same thing being called with different names. And then I think it's, I've just got a follow-up question, but I think I'd rather put that one to Eugene in terms of how is the unslaked lime or calcium oxide manufactured?
Yeah, thank you, Prince. It's part of the lime production process. And, you know, I must say, whenever we take customers down to the Northern Cape to take them through a lime production process, I always find they are quite astonished at the detail that's involved. But to your question, let's perhaps share with our listeners a very basic process. So in terms of the manufacturing, it's really just starting off with the limestone, which I alluded to earlier on. So blasting, screening, crushing, screening, to get to a particle size of limestone that will then be fed into the kilns, and that is really what we call kiln feed. So that is a 50 millimeter limestone by way of example. That limestone then goes through the kiln with coal dust that we blow in, and we run at around 1300 degrees, and the limestone moves through the kiln, burning off the carbon dioxide. So it loses about 44% of its weight. So if you put a ton of limestone in on this side of the rotary or shaft kiln, you're losing 44 or 440 kilograms by the time it gets to the other side. And that is also why customers tend to buy burnt lime as opposed to limestone in the pyrometallurgical industry. So at the end of the kiln, once it's gone through the burning process, you have unslaked lime. So fundamentally, it's really just limestone that has been burned at 1300 degrees, burned off the carbon dioxide, and you have a quick lime, burnt lime, or a calcium oxide on the other side. Of course, as it comes out of the kiln, I always say it looks like our charka braai briquettes, not black, but brownish in color, but a similar shape and size. And that is what we would call our -55 plus 0 run of kiln. So that's how it comes out of the kiln. And from there, there's another beneficiation stage, which perhaps our listeners would like to know about later on. And that is really when we get into the milling and again, some screening and hydration process before it is packed into the various packaging. Thank you very much, Prince.
Yeah, thanks, Eugene. I think quite interesting. There was a poll being run in parallel in terms of, I think it was just one question, which is, what is hydrated lime? And then there's been 4 possible answers. I mean, obviously with one correct answer, and I think it's 5. Well, the first possible answer was limestone with added water, and then there was also calcium oxide. There was also a sedimentary calcium forming on the seabed. There was also calcium carbonate and calcium hydroxide. So then I just want to put this question to Justin, then as part of giving our audience what is the correct answer. Justin, what is hydrated lime? Then at least you can have an opportunity to offer some guidance based on the poll that Elmin has been running in parallel.
Great, thanks. Yeah, well, hydrated lime is the correct answer to that. Is calcium hydroxide. And if we look at the little triangle that you've actually got on your screen as well there, the next step after quicklime is to hydrate the lime. And it's another process that happens. And again, the hydrated lime has a specific application for certain customers. Now, I'm going to speak specifically about dry hydrated lime powder. If you put additional water with it, then you get to what we call the milk of lime or your lime slurry, which you can produce out of quicklime or out of hydrated lime. But effectively, the process is to, in a mechanical or a process environment, add just enough water to the quicklime, and it's a chemical reaction effectively that absorbs the water into its chemical structure. And you go from calcium oxide, which is CaO, to calcium hydroxide, which is CaOH2. So one oxygen comes from the quicklime, and the other oxygen basically comes from the water, and you've got the hydrogen in there as well. And if you get that ratio right, it's an exothermic reaction, and there are safety issues with that, obviously, with that process. It drives off quite a bit of heat, but effectively it comes out dry on the other side. And that was the one thing that I just found majorly fascinating in the process. You add water to a product and it comes out dry the other end again. But it's purely that chemical process. And in the process now, what happens as well is the quicklime actually expands as well as it hydrates. So the bulk density is important, and that'll come in on the costs that we may discuss a bit later on. Effectively, the volume increases by about double. So if you're transporting 1 ton of quicklime and you want to transport the same amount of lime as hydrated lime, you'd have to transport 2 cubic meters, literally, because the bulk density is roughly half of that of quicklime. So 1 cubic meter of quicklime would typically weigh about 1,000 kilograms, 1 ton. 1 cubic meter of hydrated lime, somewhere between 350 and 600 kilograms, somewhere around there. So you'll see that the volume increases quite substantially. And that comes in, then gives you the issues with the transport of the product in there. But effectively, the hydration process is done on a commercial scale as well. You run that through a hydrator, and it's effectively a mixing device that mixes the water that you spray in a metered manner. You know what your feed rate into the unit is in terms of the product, and you know your water feed rate in, and out of the end comes a warm, dry, hydrated lime. And that is then distributed to various customers in that form if they want it. That's effectively the process, Prince.
Yeah, thanks, Costin. I think it's worth mentioning to say about 62% of our guests got the question right. So with 38%, I think we'll all walk away here knowing better in terms of what is hydrated lime. I think, Costin, with all these types of lime available, how does the end user decide which product is correct for their application or process? Maybe let Eugene go first with this, and then I think, Costin, I would like you to chip in as well in terms of the Eugene, you can go with this. Let's go kick off with you on this discussion.
Prince, thank you very much. I think that is, for me, one of the most important questions that we deal with on a daily and regular basis with specifically new customers, but believe it or not, even existing customers. And I'm going to try and summarize it without providing a thesis, because I certainly don't have the answers to all the questions, and Carsten has also been able to assist us in the past. But I think it really starts with the industry in which the customer operates. Water industry, small plant, hydrated lime in either bulk tanker, bulk bag, or 25 kilo pocket. So if it's less than 100 tons, normally makes economic sense to use hydrated lime. Soon as the volumes are up at the 1,000 tons, like these big water treatment plants, the Eastern Basin, Central Basin, Western Basins, you'll find they change immediately to unslaked lime, and they do the mixing or hydration in terms of a milk of lime on site. So already the water treatment on site and the industry they operate starts steering towards a direction. Of course, if we then look at the steel industry, lump lime, because it gets poured into a furnace, and of course you don't want any dust because it will just get blown out of the stacks, and they will lose money because the dust is fundamentally still an unslaked lime. So there again, we start focusing on lump lime delivered to the customer with a high reactivity or a high RDIN. And then if you look at the gold industry, they really just want a very fine product that they can put through their slakers, high volumes, quick reaction with their process, and they can then move on and extract the gold. So fundamentally, it's really about interacting with your customer. And I always say, you know, I think sometimes we must just learn to listen. My wife says the same thing. One day I will manage the art about listening. But I think seriously, let's go and listen to the customer first, then take the information, bring it to Techmatic, bring it to the lime producer, and then put together a solution, because it's about industry, it's about application, it's about existing equipment on site that may be archaic and needs replacement, new technology where Techmatic can play a role, and then we come forward with a final solution. Karsten, maybe you want to add?
Sorry, Karsten, I think you are muted. If you can just unmute. Yeah.
Sorry for that. Yeah, just I think I can't add too much to that. I think Eugene's given most of the answers on that. So I think, Prince, if you can maybe just grab the next question.
Yeah, I see there's another interesting question that came from the guest. I'll go to it. I've just got a follow-up question as well. I think from the earlier discussion, Eugene, you were talking about actual lime availability. I think you've mentioned a percentage of in South Africa, maybe in the region of 95%. Other areas or other countries, you were mentioning about 99%. That only says one thing, to say within that lime, there's some impurities or there's some foreign products which cannot be classified as lime. So then so my question is, in terms of the particle size and the grades, how does this influence the lime selection for downstream process? I think, Karsten, if you can go first on that.
I think that is a very, very important process or question, because you know, you don't, in the sort of theoretical world, you get 100% pure lime. But if you actually mine the product, you do get lenses of, say, for instance, silica or something like that, that gets mined with the actual product. And when that gets burnt, the silica does not convert to quicklime, and then it remains a solid piece of rock, for instance. And if that's not ground down to very fine product, it remains in the process. So if you, for instance, use a slightly more coarser lime in your process, those coarse particles could actually be little particles of silica, for instance, which could damage your downstream process in terms of pumps, agitators, and that sort of thing. So it's very important to have a look at what is available in terms of lime, firstly, and what you're going to use it for. And because if we do use a coarser lime and we have to get rid of that grit, it obviously changes the equipment that's required for processing. So you really have to look at the application and have a look at what is available. And that's where the lime producers and we as Techmatic can get involved with making those decisions in the end as well, in terms of, you know, what is right for the application. Eugene, I think if you maybe just want to sort of elaborate on that as well.
Karsten, yes, thank you, and thanks, Prince, for the question. I'd like to just clarify one point in case I may have misled our listeners. Correctly, as stated by Prince, available calcium on limestone is about 95 to 98%. I think what is important to note, and I didn't state it, so my apologies, is once you've burned the limestone, the availability or the available calcium drops to anything from 85 to 89%. Now, you may say, why am I giving you a range? And that is because Mother Nature and burnt lime have a love-hate relationship. And that is, as you produce a burnt lime and it comes out of the kilns, if it's raining in the Northern Cape on that specific day, you will battle to continue having an 86% available lime, because Karsten alluded to this earlier on, the unslaked lime particle starts reacting with the water or the moisture in the air, which reduces your available calcium. If it's a dry, hot day, like it normally is, 89, 90% is quite achievable. So I just want to qualify that burnt lime is around, let's say on average, 87, 88%. But to the grit question, and I think that is for me one of the most critical parts of our industry that customers sometimes overlook. And I had the fortune and honor to be with a customer on site in the Northern Cape for a week late in February. And the young lady engineer, female engineer, spent some time with me, and she said, Eugene, I don't understand grit. And I tried to explain to her what Carsten just took us through. And she said, you know, we've got this daily tonnage that we throw away. And I said, well, two things. Let me explain to you the Nesquik principle. And she said, what's the Nesquik principle? And I said, you know, when you make milk, Nesquik for your kids, the strawberry one, and you pour it in their glasses, when they finish, what's at the bottom of the glass? She said, there's still a bit of Nesquik left. I said, that's grit. I said, so if you can take that Nesquik and just mill it a bit finer, and you pour it back in the milk, there will be nothing left. And that is why you should have fine, unslagged lime. Up to 600 micron is what we produce. There is no grit. And she said, you know, Eugene, I now understand grit. As luck would have it, the next morning when we got back to the plant, there was no grit at a slaking plant. So fortunately, my Nesquik and the practice certainly showed one and the same answer. But I think the last point I want to make, Prince, and sorry to elaborate on this and carry on about it, but it's really about money. Within grit, and Carsten alluded to it, is really about 11%. So if you produce an 89% available calcium, there's 11% of insolubles. That is what it is. It's what Mother Nature gave us in the Northern Cape. However, in the grit, every ton that you throw away, there's up to 45, maybe 48% of available calcium that you're throwing away. And we've known that for many years. We test it. Whenever there's grit, we say, please, Mr. Customer, let's test it for you or test it in your own laboratory. So you're throwing away up to 50% of calcium that you're paying 2,000 or 3,000 Rand for delivered to your plant. So grit I see as a double-edged sword. A, you have to throw away something that costs money in terms of removing it. And two, you're throwing away something that has available calcium, which you buy at the front end of your business to perform a certain task. So for me, finer is better is my motto. And certainly, if you can then process it to Carsten's point, it will go through your process, no grit in your slaker, no grit in your holding tank, and you will not be wasting money. Thank you very much, Prince.
Yeah, thanks, Eugene, for that example as well. I think we should treat it like a glass of whiskey. I've never seen anybody leaving anything behind. So if they go with a fine line, then
I love it. Love it.
Because of not wanting to waste, obviously. And then, yeah, and then what cost implications should be considered when considering line types? And I think maybe, Eugene, you can just follow through on your earlier discussion. Just one of the questions coming from the guest.
Yeah, I think, you know, I don't want to repeat what we said earlier on about application. But I think when we start looking at cost implications, first of all, industry again, and Carsten described it quite aptly. It's about water industry, it's about steel industry. So first of all, look at the industry. Secondly, look at the lowest cost in terms of available calcium. You know, everybody says, well, you know, a ton of lime cost X. And I'm saying, well, a ton of lime means nothing. What are you paying for available calcium? So secondly, in terms of firstly, application or industry. Secondly, look at what you're paying for available calcium. And then thirdly, what I think sometimes we overlook is how we package and how we order. So I've seen many a time customers says, well, I've been ordering 25 kilo bags. I said, but if you get a company like Techmatic to change your bulk handling facility, and you can change from pockets to bulk bags, there is a cost saving. So again, your cost per ton comes down because bulk bags tend to be cheaper than 25 kilos on a pallet shrink wrap, as an example. And then, of course, lastly, term we used yesterday in a meeting is just-in-time delivery. When you deal with, particularly in the steel industry, high volumes, high consumption, and you bring in this reactive line, and then they put it in a bunker and it starts raining, and the quality of the line reduces. And I always say, a huge cost saving can be in terms of a just-in-time delivery. You don't have to carry 5,000 tons on a steel-making site when you have a lime plant just down the road or a beneficiation plant just down the road. So, you may say, well, it's small increments, but the small increments, when you're using 10,000 tons or 1,000 tons in the water industry, is important. And lastly, on that point, one of our strategies is to go and work with a customer to reduce their lime consumption. The customer says, but I don't understand, Eugene. You and your colleagues come to us and you reduce lime consumption. And say, if we reduce your lime consumption, you'll see it on the bottom line. But you'll also remember the supplier to say, hey, they got me to use the right product, the right packaging, and got my cost per ton down. So I think there are various applications and various parameters that can affect what is the cost, or the input cost as to lime. And I've just alluded to a few of that. I'm sure our guests can perhaps raise another few as well. Thank you very much, Prince.
Thanks, Eugene. I think, Custin, you'll have, yeah, go ahead.
Yeah. I think one of the other important things is obviously transport, and specifically I'm going to refer to your hydrated lime and your unslaked lime. I mean, the distances here in Africa are quite extensive, and if you have to transport your lime from a producer to an end user, we could have the transport costs actually way outweigh the actual cost of the product itself. So if you running lime, a distance of maybe 1,000 kilometers or something like that. And the one issue there is quicklime is obviously denser. It has not got the water in it that the hydrated lime has. And over long distances, it's normally more efficient to transport quicklime because you don't transport water. And then remember when I said earlier about the bulk density, if you transport 1 ton of quicklime, you would have to, or 1 cubic meter of quicklime, which is 1 ton of quicklime, you transport a volume of roughly 2 cubic meters of hydrated lime. So you need double the number of trucks to get the same amount of calcium to the actual end user. And obviously that pushes the transport costs up. It effectively doubles the transport costs. And you also got a percentage of water in the product now, which is bound in the crystal structure that you're also transporting across the countryside. So it's very important as well for the, when the customer is looking for a specific lime, is for them to speak to the producers and have a look at the logistics behind it as well. And you'll see that, for instance, Central Africa, they predominantly use quicklime on the mines there because it's just more efficient and more cost effective to transport that, across the long distances that some of these mines actually need it transported. So I think, transport, the logistics behind that, very important factor as well with the actual cost consideration. Thanks, Prince.
Yeah, thanks, Custin, for that. Thanks, Eugene. I think well explained. And then I just got another question here from the guest. What is the difference between Port Shepstone limestone and the Northscale limestone?
So I'm going to answer it without you inviting me, and it's again a great question. So I'm going to start by perhaps just describing what the Port Shepstone limestone is being used for. First of all, it's the whitest of white limestone that you certainly would find in South Africa, and we always say it's for the paint, paper, and plastic application. So if you look around, anything white that you see right now on your desk, Prince, has got most probably our white limestone from Port Shepstone. The trading name is the Kulu product, or the brand name is the Kulu product, and been around for many years. So all the paint producers, all the paper producers, all the plastic manufacturers, and I say all, mustn't be too arrogant, but I think a big portion of the respective industries use the white limestone. The difference is fundamentally that there's still the same availability, slightly less, about a 94% average in Port Shepstone versus, as I said earlier on, about 97% up in Danielskuil, but a pure white limestone. And the process there is slightly different. We don't have kilns. We have a floating process to produce a very, very pure and a very fine limestone for different applications. So in the end, the one is a floated process or limestone process, whereas in Danielskuil, screening, crushing, and burning process. And of course, fundamentally, color difference. Pure white in Port Shepstone and brown gray in the Northern Cape, Danielskuil. I hope that answers our listeners' question. Thank you.
Certainly it does, Eugene. Thank you very much for that explanation. I think I'm not seeing any other question coming from the guests, and I must say thank you, Kirsten. Thank you, Eugene. I must just hand over back to Almin now, and to our guests for participating. Thanks. I think there'll be more of this. Almin, you'll elaborate more in terms of what's next. I'm really excited about these webinars. There is so much insight that one can get out of it. And Almin, over to you.
Thank you so much, Prince. Okay, I think thank you everyone for joining us today for this informative and engaging webinar on the process of lime production. I hope you've all found it as interesting and informative as I have, especially the next quick explanation. We've had the privilege of hearing from 3 distinguished experts in the field. Thank you, Prince, Kirsten, and Eugene. They've shared their knowledge and insights on the various types of lime, the production process, and the importance of selecting that correct lime type for your application process. So I hope you've all gained valuable insights into the lime production process and how it can be applied in your industry. Remember, the recording of this webinar will be uploaded to our YouTube channel. So if you've missed any part of it, or perhaps you want to watch it again, you can access it there. Then we're very excited to announce that our next webinar is scheduled for August this year. And during that webinar, we will be discussing the process of lime slurry production. So keep an eye out for more information on that in the coming weeks on our social media channels. So once again, I'd like to thank our guest speakers and all our attendees for making this webinar possible. I hope you've all found it valuable, and we look forward to having you join us again in the upcoming event. Thank you, and enjoy the rest of your day.
Thank you, everybody. Appreciate it. Bye-bye.
Well, thank you very much. Cheers. Bye.
Thank you, everyone.